Hello, and welcome to the course. I'm your host today, Drew Dodlin, and I'm speaking with Professor Wah. Professor Wah teaches in the University of Chicago's Department of Physics and the Enrico Fermi Institute. He was one of 3 University of Chicago professors named as a Fellow of the American Physical Society in October of 2021 for his notable contributions to the fields of quantum and particle physics. He's here to talk to us about his career path and how he became a University of Chicago professor. Welcome, Professor Wah. Could you tell me how you got to the University of Chicago? What led you to the school?
It's a very interesting question, and I think my experience on this is unique. So when I finished my PhD work at Yale University, I want to continue in research. So at the time, it turns out this is in early 1980s. The research lab at Europe called CERN, the European Nuclear, Accelerator Complex thing, was very fashionable. Many good things were going on. So, and I wanted to go there to continue my research. So at the time I asked my advisor in graduate school, what does he think? And he actually gave me an advice, which I never forget. He told me at the time, no, you should stay in US. Don't go to Europe. In fact, go to University of Chicago. I was a little bit surprised by that answer, but then I looked into U of Chicago, physics department and all that, and here I am. So that's how it gets started.
Do you remember what the reason was that was given of why you should stay?
Yeah, I think it turns out my advisor also got his PhD from University of Chicago. And he was a student of Enrico Fermi. And I don't know if you guys all know that Fermi was the person who basically invented the atomic bomb and, that kind of thing. And so my advisor was a last student of Fermi. And I think in my advisor's mind, I'm just guessing now, U of Chicago is a good fit. It's one of the great places to study particle physics at the time. So I think that was the reason.
Do you remember back in school, maybe around high school, did you start having an interest in physics back then, or when did this start for you?
I think my love for physics came from, it is a second year in junior high, and it was completely motivated and initiated by my physics teacher at the time. And because, I was just like everybody else and was scared about physics all the time. And 1 year before I have this particular teacher was very difficult. I could not understand anything. Everything seems to be a mess. And so in the second year of junior high, when I have this new teacher, and he made physics so much easier and fun, from the most difficult subject to become the easiest subject. And then I was so shocked. And then I started to really like the subject, and then it sort of slowly took off from there.
Do you think you took any specific sort of lessons from him in the way that you became a teacher yourself?
Yes. It turns out, because of this person's ability to present physics, high school physics for that matter, in a way that is very logical, very clear, very understandable. It's not some, difficult subject at all. And that matters a lot because he communicate to us that, all these difficult problems is actually very simple. And that really caught my eyes and mine. And for that matter, actually, I have to say, in my junior high school class of that year, several of us in that class became professional physicists later on in life. And I think it has something to do with this teacher. It's obvious to me. And
that's amazing. Yeah.
Yes, it is. It really is.
And so, did that spark an idea of you becoming a teacher? Like what ideas did you have about what you wanted to do within physics at the time?
Yeah, I think at the time, physics, I did not think about teaching at the time. Most of the time I thought I just want to know more about physics in general, because that's to explain how things work and all that. The interest in teaching came much later, after I become assistant professor in University of Chicago, because at the time I need to teach a big college class, and that really motivated me. The teaching is such an important part, for me to move forward.
What do you remember about some of those earliest experiences being a teacher?
I do remember when the first big class I taught, about 100 students, and they are science major, not necessarily physics. For example, a pre-medical major or chemistry or engineering or something like that. And of course, I was young. I was at the time, young compared to now. And I really want to teach well. And so at the time, I remember I keep on thinking, I want to transfer my knowledge. I was so focused on what I want them to know. And that was not even close to good enough. Okay. And that was a problem. So I learned, and slowly through the years, I think the most important part of teaching is nothing to do with the material. It's the ability to communicate with the class and find out why they understand or why they don't understand and stuff like that. Yeah, it's amusing. It took me several years to realize what happened, to be a reasonable teacher about that.
Yeah, you're saying it can't just be a one-sided thing. You have to listen.
Exactly. Yeah. Exactly. And find out the reason why people, why students do not understand what I just said. Is that the fact they don't understand, or is it the logic was wrong, or, we are biased by our own experience and stuff like that? Yes.
What have you found that helps encourage students to communicate that? Because I have to assume that a lot of students wouldn't openly talk about, why they're confused, right? So is it about making them comfortable? Like, what have you found is effective towards making that happen?
I think from my side, of course, people have their own, personality, right? If one is an introvert, it's very difficult to just, for them to just openly talk about things. And I mean, because some of this is personality. However, I do find something I can do to help to improve the situation. And that is to make the environment less competitive, less threatening in the class. And for example, it's especially for a larger size class, nobody wants to ask any question, right? Because part of it is peer pressure. So if I stick up my hand to ask a question, maybe I'm the only one who could not understand what the professor has said. And that really not a good motivation to ask any question. And that is a huge problem. And so the question is then, how do I provide an environment or the atmosphere so that to relax this kind of thing, so that students could feel freely to ask anything without that peer pressure. And that is not an easy thing to do.
What is sort of a typical day like for you, just as a professor? You're doing research and also teaching, I understand?
Yes. So, at the University of Chicago, we teach about 2 classes per year. And we run in a quarter system. So I would say my teaching load is about two courses per whole academic year. It's actually, comparatively speaking, within the U.S. university system, it's a very light load. So my time typically is divvy up between the teaching part, which is, some small percentage of my time. And most of the time is on research, because, I'm an experimentalist. So, and it's all the detail, the know-how, the planning, and then, of course, the physics problem, is always hanging over our head. What is it that we want to measure? Why is it so important? And is there any other way to do it better? Stuff like that, yes.
What has been the most challenging part of being a professor for you?
I think, I'm going to say maybe I'm not 100%, but I'm pretty sure though. I think the physics issue, the thing that we want to pursue, the knowledge is always there. We don't know what we don't know. But so that part, when I said research in physics, it's a very personal journey. I just want to know when we reach the edge of the knowledge, maybe there's something new I can do more. So that goes without saying. So we spend some amount of time on that. But I think the most challenging part of my work is how to organize, how to operate a group, because I cannot do the experiment myself. It's mildly complicated, to say the least. And so within the research group, we have student, postdoc, various level. And I think in order to do a good job on this kind of research, I think communication and how to organize a group so that everybody can perform at their maximum. I find that part is one of the most challenging part of doing research. It's nothing to do with the subject itself, but to do with how we organize ourselves and how do we, the non-science part.
Yeah.
Yeah.
Is there advice that you would give to someone who's entering into your field right now?
Yeah, I think, besides the usual, work hard and stay focused. And, I'm going to say, research and at the research level to search for the unknown and gain new knowledge is sort of like religion, and we do it because we just want to do it because we believe in it. We believe in the philosophy. We believe it's going to do some good. Or not, it does not matter. Yeah, so we do not need to, so the advice is just stay focused and pursue what we think is the most important, problem in physics and go for it. And on the way there, we will have many obstacles, just like anything else. But I think I believe the most difficult part is to stay on course. And yeah, it's to stay on course.
You've been at the University of Chicago for a long time. What has kept you there? What has stopped you from going somewhere else?
It turns out, I would say, the University of Chicago, especially the physics department, has a great atmosphere. And I think it's dated from the history of the department and also all the wonderful physicists that passed through, our department. And in particularly, the university has provided very good infrastructure to do research because, to do important experimental work, it is more than just a physicist sit down and think about what to do. But the support, for example, in this experimental work, we need a lot of engineering help. We need a lot of computing help. And in fact, on things that we want to do, and it is not clear what is the right thing to do. And the university actually helped a lot on how to enable the physicists, to do their research. And I think that is unique and quite intense at this university. And I think that really kept me here. I do not think about going anywhere else unless that requirement is satisfied. As far as I know, it's not so many places that have such an infrastructure support.
Are there specific goals that you have, aspirations that you have for the rest of your time that you'll have there?
Oh, I believe in the physicist career. I think all of us want to understand how the world operates better than before. But it turns out, obviously, it's not an easy task. And in fact, it's a lot of luck. So in my wishful thinking, I wish we can find something important, something significant and help to understand physics in the current ongoing experiment, which likely to be the last experiment I will perform. Yeah, that's the, I don't know how to say this. That's the wishful thinking part. Yeah.
The way you've phrased it is that you want to know more than we know before, because obviously we're not going to know everything in our lifetimes, right? Is it difficult to become satisfied with what you've learned? Have you figured out a way to be satisfied?
No. So I can get into maybe the non-technical part of what I mean. In physics right now, in the fundamental physics level, we have two major, well, there are many, but really two major problems stands out. And one is they call what is dark matter, and the other one is what is beyond the physics we know. We call that the standard model. And so the question is there non-standard model, things behind what we know? And so these two particular directions, our whole professional field physicists are all pursuing in different way. I wish, I hope we could find some solution. We will find the evidence soon. But of course, as you mentioned, it's not up to us. It's up to the truth. And it is a long road. It will be good if we find out the solution to these questions, and which is important, I think, for humanity reason. I really mean it. We have to know.
Thank you, Professor Wah, for your time today, and course takers. If you enjoyed listening to today's interview, please check out the other ones. You can find out more about the University of Chicago through uchicago.edu or the university's campus in Hong Kong through uchicago.hk.